Okay, I want you to picture the entire lifespan of a typical car. The manufacturing, the years of daily commuting, the endless road trips, all the way to its eventual trip to the scrapyard. Now, multiply that whole shebang by 5. That massive, staggering amount of carbon emissions, that is exactly what it takes to train just one single large AI model today. I mean, it's a completely jaw-dropping statistic, isn't it? As our artificial intelligence gets smarter, its appetite for power is literally pushing our current computing infrastructure to the absolute brink.
But here's the thing. Nature actually solved this problem millions of years ago. Listen to this incredible quote from Princeton University's Tianming Fu. He said, "The real bottleneck for AI in the near future is energy. Our brain consumes only a tiny fraction, about 1/millionth, of the power consumed by today's AI systems to perform similar tasks." 1/millionth. Think about that. Our brains are essentially the ultimate supercomputers, and they run on less energy than a dim light bulb. And honestly, this realization, it's sparking an absolute revolution in how we build machines.
So welcome to this explainer. I am so thrilled you're here with us today because we are looking at something truly mind-blowing. We are exploring what's called the biotech convergence. We're standing at this exact pivotal moment in history where cutting-edge technology and actual biology are rapidly merging into a single, breathtaking future. It's wild stuff.
Okay, let's dive into this. Here is our quick roadmap for today. First, the computing energy crisis. Then, building brain-inspired hardware. Third, intelligence without a brain. Fourth, next-gen consumer tech. And finally, we'll wrap up with the biotech convergence.
All right, starting us off with part 1, the computing energy crisis, or what I like to call the brute force approach. Right now, our primary method of computing relies heavily on raw, energy-hungry silicon power. And to see what this brute force approach looks like at its absolute peak, we really need look no further than the massive Pangea-5 supercomputer. So French energy giant Total Energies is pouring over 100 million euros into this machine, which launches in France in 2027. It's going to multiply their computing power by 6 times for super complex tasks like seismic imaging. Now, to their credit, they've engineered an impressive 40% energy reduction, and they're brilliantly recycling the residual heat generated by this supercomputer to warm buildings hosting over 2,500 people. But, it proves a really massive point. The energy industry itself is becoming a massive consumer of AI power. Relying purely on this brawn is hitting an absolute wall. We desperately need an alternative. Let's move to part 2 and see how this builds. Building brain-inspired hardware and the biological epiphany. So, if brute force is just too power-hungry, how exactly do we compute smarter? Well, the answer lies in mimicking biology. Researchers over at the University of Cambridge have developed a real game-changer of a breakthrough called a memoristor, which is short for memory resistor. But utilizing a very specific crystalline structure of a material called hafnium oxide, this microscopic device actually mimics neural connections. And get this, it can cut AI energy used by up to a staggering 70%. But you might be wondering, why on earth is it so efficient? Well, it solves a fundamental flaw in how computers have worked for literal decades. So, looking at traditional computing, it suffers from what's called the von Neumann bottleneck. Basically, your computer burns massive amounts of energy just constantly shuttling data back and forth between the memory and the processor. It's like a never-ending digital traffic jam. But biological computing via these memristors solves this entirely. Just like the actual neurons in your head, the processing and the memory happen in the exact same physical place. No data movement, which means no wasted energy. And this leap is brilliantly illustrated right here. Think of a top-tier traditional GPU as our 100% baseline for energy consumption. A conventional memoristor cuts that right in half. Then, the new Cambridge memoristor drops it all the way down to about 30%. But dropping all the way down to the human brain, it runs at about 0.0001% of that baseline energy. I mean, no way, right? We have so much room to grow, and that humongous gap is exactly why researchers are turning to actual living biology. Which actually brings us to one of the most astonishing scientific breakthroughs of 2026, Princeton's 3D Mind platform. Guys, they aren't just mimicking the brain anymore, they are literally using it. This chip embeds 70,000 living lab-grown biological neurons within a soft 3D electronic mesh.
The cells actually grow right around the mesh, forming a direct interface with the computing hardware. And remarkably, they've achieved stable interaction for over 6 months. This isn't just a huge step for ultra-low energy AI. Scientists could actually use neurons from patients with Alzheimer's or Parkinson's to test potential treatments directly on a living, functional neural network. It's absolutely crucial work. Now, let's push this even further. Part 3, Intelligence Without a Brain, Redefining Smart. So what if you don't need a processor, software, or, even a brain at all to be considered smart? Enter embodied intelligence, which is also known as morphological computation. This is the wild concept that intelligence can be encoded entirely in a physical shape's interaction with its environment. Researchers at Leiden University in the Netherlands have actually created microscopic robots, we're talking smaller than the width of a human hair, that navigate complex environments using exactly this principle. So let's break down how these brilliant, brainless microbots actually work. They are created using a nanoscale 3D printing technique called two-photon polymerization. First, you apply an alternating current electric field. Next, the flexible shape of the robot selectively contracts and expands in response to that field. And finally, this physical deformation allows it to actually swim, avoid obstacles, and navigate really narrow channels. These things are between 0.5 and 5 micrometers long and require absolutely zero software or sensors. Imagine, just for a second, swallowing a pill filled with these simple, fail-proof microbots that automatically navigate your bloodstream to deliver targeted medicine directly to a tumor. It's like science fiction coming to life. All right, moving on to part 4, next-gen consumer tech, the future in your hands. Now, you might be thinking, okay, this is all amazing lab science, but what does it actually mean for me today? Well, let's shift gears, because this convergence is already hitting your hands. Take our smartphones, for example. Samsung recently rolled out the One UI 8.5 update for the Galaxy S25 and S24 series. Built right on Android 16, the massive headline here is agentic AI. We're finally moving past the days of AI just sitting there, waiting passively for your individual commands. Agentic AI acts autonomously on complex, multi-step tasks. So if you tell it, hey, prepare for next week's trip, the AI acts as a proactive agent. It checks your flights, books the hotel, and creates packing reminders all on its own. But Samsung actually took this biotech convergence a step further at Display Week 2026 with their brand new Sensor OLED screen. Honestly, forget needing a smartwatch to track your vitals. With this tech, first, you just place your finger directly on the OLED screen. Then, organic photodiodes built invisibly right into the display emit this green light. Finally, the screen analyzes the light reflected by your blood flow to detect your heart rate and even estimate your blood pressure. They have literally turned a standard 500 pixel per inch display into a continuous built-in health monitoring tool. No external wearables required. Now, what's really interesting about this is how they balance that functionality with privacy. Because on one hand, Samsung introduced the Flex Chroma Pixel, which blasts an incredible 3,000 nits of brightness, so your screen is totally flawless even in direct sunlight. But think about it. If your phone is now displaying your sensitive medical data, you definitely don't want everyone on the subway seeing it, right? So they pair it with this clever privacy display technology. It uses directional light control to create strict viewing zones. Basically, only the person looking dead on can see the health metrics. From any side angle, it is completely hidden. And that brings us to our final section, part 5, the biotech convergence and the big picture. So the crucial point to take away from all of this is that from supercomputers down to the smartphone in your pocket, technology is fundamentally reshaping itself in the image of biology. And this convergence has kicked off a massive global race, with different regions capturing specific pieces of this puzzle. The United States is really pushing the boundaries of AI research and deep bioelectronics, like that living Princeton ship we talked about. Europe is taking a strong lead in sustainable tech and extreme energy efficiency, which we saw with the Pangea-5 and those tiny Leiden microbots. Asia continues to absolutely dominate the consumer application and display sectors, turning these high-concept ideas into everyday tools. And meanwhile, China is pouring heavy investment into neuromorphic computing, which are chips designed specifically to act just like human brains. And that leaves us with a pretty profound thought to end on. As we successfully merge 70,000 living biological neurons with electronic circuits to create these ultra-efficient AI chips, where exactly is the line between a tool and an entity? Now, the researchers assure us these are lab-grown cells with zero consciousness. But as this technology inevitably scales up to millions or even billions of neurons to rival human brain efficiency, that line is going to get really blurry. It's a fascinating and maybe slightly dizzying future we're stepping into. Thank you so much for joining me on this explainer, and definitely keep your eyes open.
because the future is way more alive than you think.